Now let's look at a problem dealing with perimeter. A rectangular field has a length of 50 yards and a width of 30 yards. If fencing cost $6.50 per foot, find the cost to enclose the rectangle with fencing. We're going to start off by giving ourselves a quick sketch. We have a rectangle. We're told that the length is 50 yards. We're told that the width is 30 yards. Now, let's begin by finding the perimeter because we're going to have a fence running along the perimeter of this rectangular field. So we're going to have the perimeter equals twice the length plus twice the width. So the perimeter is going to equal 2 times 50 plus 2 times 30. This is going to be 100 plus 60. So the perimeter is equal to 160. Now that's yards. So what we're going to have to do is to find the cost, we have to look at this as cost per foot, which means we're going to have 160 yards multiplied times 3 feet per 1 yard multiplied times our cost, which is $6.50 for 1 foot. Now, we're going to have to multiply here. And one thing we can notice is if we take the 160 times the 3, let's do that over, well, we're going to end up with 480. We're then going to multiply that times 650. So we can do that, 6.50, and let's go ahead and do the multiplication. We're going to end up with 40, 24, and then we have a 0, and then that's going to be 48. Carry a 4 is 28. And we're going to have 2 decimal points, places behind the decimal point, that is. And we end up with our value, which is going to be $3,120. Notice that in our situation, we had the yards canceling, the feet canceling, so we know that our unit is correct. So $3,120 would be our result. Now let's look at a problem dealing with the measures inside of a polygon. Find the sum of the measures of the angles of a 12-sided polygon. We're going to use a formula in order to figure this out. And the formula has to do with the number of triangles that we'd end up with inside of a 12-sided polygon. Turns out that we're going to end up with n minus 2 polygons, or triangles that is, each of which would have angle measures of 180 degrees. So we're going to have 12 minus 2 multiplied times 180 degrees. That's going to be 10 times 180 degrees. And multiplying gives us 1800 degrees as the result. In part B, we're asked to find the measure of an angle of a regular 12-sided polygon. Now here you need to understand the meaning of the word regular. If we have a regular 12-sided polygon, that means it's equiangular and equilateral, meaning that every angle has to have the same measure. So if we take the total of 1800 degrees and we divide that into 12 equal angles, we come up with 150 degrees as the measure of any one angle. Now we're going to look at a problem dealing with a tessellation. Explain why a tessellation cannot be created using only regular octagons. Now a tessellation means a tiling of the plane. So that means we could take octagons, placing them next to each other, and end up covering the entire plane. Well, let's look at this algebraically. That is, what do we know about the sum of all of the angles in an octagon? Well, we know that that's going to be equal to n minus 2 times 180 degrees. So the n is going to be the number of sides in the octagon, that's 8. So we're going to have 8 minus 2, which is 6. 6 times 180 degrees is going to equal 1,080 degrees. Well, we're talking about a regular octagon. So let's look at one angle in that octagon. That's going to be the sum of all of the angles divided by the number of angles, which is 8, and that gives us 135 degrees. Now, we know that if we're going to have a tessellation, then where the vertices meet, let me just go ahead and kind of quickly sketch that out. Wherever the vertices meet, they all have to meet together, and that would form 360 degrees all the way around. Now, let's see if we can make that happen when we have an octagon coming together. So we're going to have 360 degrees. We're going to have to divide that by 135 degrees. The thing is, that does not come out to be even. It's going to be 2 2/3. Now, what that pretty much indicates is that we'd have to have two angles at 135 degrees. Those would come together and give us 270 degrees. But if we try to add now another 135 degree angle onto that, we're going to end up with 405 degrees. That's going to be too large for one full revolution. So what would occur is we'd have very large angles coming together. Let me kind of quickly sketch that out. That'd be one of them. And then we'd have another one coming in. This would be 135 degrees. This would be another 135 degrees. And then this measure is going to be too small to fit another octagon in. And so for that reason, we're not going to be able to create a tessellation.